My name is Thomas Van Zuiden. I work for the Interac Corporation, and my title is Senior Data Scientist. Kind of just the nature of the winds, unfortunately. Like, you could kind of see where the political landscape was going, like at the time with the storm of political ebb and flow. I just didn't really see a career in science. I was offered a chance to do a PhD. I don't think I would have enjoyed it as much as I feel like maybe I would have now, but at the time I certainly felt like I just didn't feel like the space where people conduct science was as collaborative as I wanted. And it was very adversarial. A lot of scientists who are the brightest minds I know, and who do work together oftentimes don't work together and often race to get a paper out before another scientist who they are concerned is doing the same work as them. And so it just sort of festers a competitive culture, which is ultimately not what I expect out of science. And so, career prospects didn't seem high. I didn't really like the adversarial nature of it. And data science seemed like a way for me to quite literally apply my skills while I was looking for other career opportunities. And I happened to stick with it because it was something that I was pretty good at, and I learned a lot of new things. And since moving from job to job, I have been able to kind of basically amass the career that I expected of myself at this point. To be honest, if I had gone into law school instead, I would just be getting out now and just be starting my lawyering life within a year ago. Whereas now I have 4 years of credentials under a data science career, and there's more demand for people like us. The salaries are extremely good depending on where you want to go. Something I didn't know at the time, because when I started, the salary was quite bad. But then as I progressed, it was oh no, there's demand for these people. And so I left, and it really got better. And so now it's even crazier. If you work for certain bigger companies, it's madness how much money you can make in this field. Whereas, I honestly can't, I couldn't have expected things to go the way they have for me in such a short amount of time. It's been 4 years. Most of my day to day is kind of just messing around with SQL queries. I feel like most of my job, I'm lucky in that I don't have engineering data problems. We have a very competent data engineering team here. So when I do my queries, I don't really have issues with data quality or, needing to do data interpolation or any sort of work like that. It's more about putting things together in a succinct way so that I can actually build a model down the line that eventually gets deployed. In addition to that, so I spend a lot of my time building those data frames, because that's the hardest part. I also spend a lot of time collaborating with various business partners who are subject matter experts on specific systems. So if I'm building a fraud model, I'm personally not a massive fraud expert. I don't have police contacts. I don't understand how criminals take advantage of people's emails. I don't know how to hack a person's email without brute forcing it. I feel like a lot of our fraud agents, let's call them, have a very specific understanding of where the fraud landscape is. And so they might come to me, or I might come to them asking about just general questions, and where the conversation goes is down it goes down a hole of oh, there's this crypto thing evolving and people are sending money to this NFT merchant, and this isn't actually a real merchant. These graphs about how their funds are getting increasing, whatever, they're not. The money is gone. This is just a UI, and people are losing hundreds of thousands of dollars to these crypto scams. And so I can make a variable saying, okay, well, this crypto merchant is a scam merchant. They're not a real merchant. They take your money. They pretend that it's increasing, but the reality of the situation is that it's not. They're just when you go to take that money out and try to transform it back into cash as promised, you can't. And these people are in Bermuda or something. And so shutting that IP down is pretty important. It's also something that can be used to like infer whether a transfer, an e-transfer is fraudulent or not. So once you make those rules, you can ultimately combine them together and you can make a model to stop all kinds of these things happening at the same time. You know, this model it creates a score. From that score, you set a threshold. That threshold is used to determine how many transfers may go to these fraud agents in turn, who then examine these transfers and say, this one does look fraudulent, or this one does not. And that's kind of my day-to-day. SQL is the most important thing you'll learn as a data scientist. Try to get at least a little bit of an engineering vernacular like just try to develop the vernacular of engineering terms, like make sure that you understand a little bit about databases, make sure that you understand a little bit about the various tools you can use. You can't just code in SQL. Like you have to have a database, and then you have to have access to that database, and you have to use a URL string to like get to that database. So literally just like to connect to a database which is stored somewhere. There is a server entrance to that database, and in order to get there, you have to supply a connection string. You have to supply your username and password and access, and all this sort of like basically, there's no way to learn this unless you're in already. But like being familiar with the terminologies is useful, and watching videos and being like, oh, so this is how you gateway into a database in order to actually like query it properly using SQL. That helped me quite a bit. And I didn't even come from a SQL background. I started off coding in R, and then when I started at my first job, I just kind of like forcefully told them like, I'm not going to do this anymore. I'm going to do Python now, which is the sort of second most important thing to learn. That one, I feel like, the difference between data scientists and like insights analytics people is that a data scientist does know how to take data and build a model and then set a threshold and then really deploy a model to a production platform or a production server or a Docker server or something to actually have it be running or package it up in a Flask object, whatever. And so that is the most important thing. That sets a data scientist apart from a data analyst. The SQL stuff will still be the most important thing for both people, but by simply knowing a little bit of statistics and mathematics, you can, I don't know if it's a double, but like, at least 1.5 times your salary just by having this extra thing that literally you use 5% of the time of your work. I also think, honestly, communication is very important, being able to communicate with your business stakeholders. Like in my case with the fraud people, like I have to be able to understand what they're saying about fraud patterns. And like I said before about a scam crypto merchant, I have to be able to take that and translate it into SQL. So they're speaking English and I'm thinking in SQL. How do I turn this into SQL for our databases? And then how do I turn that into a variable? Because they're just saying these crypto merchants, blah, blah, blah. Is like, is my variable going to be continuous? Is it going to be, no, this guy is a scam artist, so just if this merchant then 1 else 0? Or is there another way to represent this sort of information? And then you have to be able to make sure that that variable is readable for your model. So you can't just have it be like some string object. You're working in mathematical space. You have to represent it either linearly or continuously, or through some means of number, some numeric means. And then ultimately, you have to be able to then run it in production. So it has to be able to be something that your program that is actually working to use the model, it has to be something that program understands. So in my case, like I will sort of serialize my model in JavaScript, and this is not a hard thing to do. It's just painful sometimes, like it's annoying. And so, you serialize like a logistic regression in Java, and you basically have to represent all the variables and all the coefficients the way that your Python object does, but in Java, until you get a better, or maybe you just, maybe you call a server that hosts the model object. I don't know, whatever it is you're doing, it has to be able to be read in all places, basically. And so I think those things are important to know, but yeah, ultimately SQL is probably the most important thing you can understand. Because if you don't know SQL, then you can't even begin to work in the data world at all. Something that would have helped me a lot is understanding the value of analyzing the model output. So in the academic space, you build a model and you say, this is what you forecast some situation that's going to happen in 10 years. And, this is what the situation looks like with, 95% confidence, blah, blah, blah. In the world I kind of work in now, I can't just, spout statistics, and I can't just say, the Akaike information criterion is the lowest of this model, and also the Gini coefficient is this, and also the kappa value is between 0.7 and 0.9. So this is a really good model. You need to go forward with this. It's more, you need to be able to deliver and derive the value specifically of that model. And so really digging in and being like, okay, my model is predicting values for each item that I am building them on. So if I was building like a content recommendation algorithm, you would have a data set that you're testing on, and you would know if the person is watching this show on Netflix or that show on Netflix. And ultimately the response is binary. Like, here's a row, each row is a show. Here's the response variables. Did they watch it? Did they not watch it? And your model should have a bunch of shows that they would like to watch, or they have watched, at the top of like with the highest probability of the output of your model. So your model produces a probability. If your model produces a 99% probability, the hope is that that show is something that person will watch. Now, within that set of binary, there's a bunch of false positives. In the case of Netflix, you might want to say to the person, hey, look at all these false positives. We should be recommending this content to this person because this is what they will want to watch based on our model's output. And understanding that, like, this is how you would use a false positive in Netflix's sense is very important, and something I did not know going into this field. And the same thing is true of me when I was building my fraud model. There's a lot of false positives where, like, your model is saying this one has a 99% chance of being fraud. And then you actually, but it's not. And then you actually look at it and it's like, oh no, they missed this one. That, the insurance agents, the bank people, they missed it. So ultimately understanding that a false positive is not necessarily a false positive, but also understanding that, you need to be able to look at all those high probabilities and be able to explain in groups of them, like, why you are saying these are high risk. And the reason you're saying they're high risk is, like, from a business sense, it's like, look, you take a slice of these first 10,000 riskiest e-transfers, there's like 1,000 frauds in there. That means that you're catching, in 10,000, you're catching 10% of 10% of these are all fraud. And that 10% represents, I don't know, half of all e-transfer fraud. And once a person, like an executive, sees that and they say, wait a minute, so you can score 10,000 transfers, you can score all our transfers, you can sort them from biggest to smallest, and you can say there's 2 million transfers in 3 weeks. You can take 10,000 from that 2 million, and 1,000 of them are fraudulent, and that is 50% of our fraud volume in terms of dollars lost. And I say yes, and they say, holy shit, deploy that immediately. That is not something that you would do in the data science world in the academic world, because that information is ultimately not scientific. It is not a deliverable. It is more, it's ultimately just like they want you to make statistical proofs as opposed to deliver value. And so the delivering value sense is very overlooked in the academic world. And so you build a model, you say, hey, it looks great based on all these statistical factors, therefore we forecast this. So yeah, it's just different outputs. And so when I moved into the data science space, like, I learned this the hard way, and I wasn't disciplined, let's say, but I was very, like, caught off guard by, like, how long it took me to be like, oh, I see what you want now. Because I just kept on hitting my head, like, don't you understand the Gini coefficient is extraordinary. Look at this kappa statistic. Don't you get it? And they're like, you're not telling us what the model is producing. Like if you can get your hands on a good online SQL course to sort of at least be able to talk around the SQL stuff, like whenever I interview candidates, I don't check my model. I don't check their modeling background that seriously because I'm working with them. And if they don't understand something, I'm going to be there to push them in the right direction. But from a SQL perspective, like if they don't know SQL, that's usually a pretty dangerous situation, because not knowing SQL is like, you don't just not know SQL. If you don't know SQL, you also don't understand inherent data structures. You might not understand the storage limits of your Python instance on AWS servers or whatever. Like you don't know why an int 16 is more useful than an int 8 in some cases, whereas an int 8 is more useful in some cases than an int 16. You don't know why date time formats have to be certain ways, have to be formatted certain way. There's just a lot of minutia that like I feel a person is just completely lacking if they have no SQL experience whatsoever. And that's hard. That's very, very hard to teach. It took me 2 years and I wasn't even learning it in SQL. I was doing like SASQL, which is SAS, but I wasn't actually writing in native SAS. I was just running SQL code in my SAS instances. And then, you kind of, at least in my case, I was learning there. And then when I moved over to a pure SQL environment, it was just like not only a lot faster because it's not using like a massive piece of software to run code. It's literally just like you have a little small window to run your SQL code in, and it just literally runs everything on an Amazon server somewhere else. And so like having that is just like, it's the foundation of everything.